Welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing of population mean when the variance is unknown. So say if we want to test on the hypothesis about the population mean mu, and actually we do not know the variance of the population. And this is a very realistic situation because when you do not know the population mean, and most probably you do not know the variance either. So in this situation, we have to use the t-distribution or student t-distribution. So when the random sample x1, x2, xn, sample size n from a normal or at least approximately normally distributed distribution with unknown mu and sigma square, then we can use this test statistic x bar minus mu divided by s divided by the square root of n. So actually s is the sample standard deviation, which is the square root of the mean squared error of each sample number value with respect to the sample mean x bar, then divided by n minus 1, then take a square root, then we get a standard deviation of the sample. So this statistic is x bar sample mean minus population mean, which we want to test. Then this part in the numerator and denominator is the s divided by the square root of sample size. So this statistic has student t-distribution with n minus 1 degrees of freedom. So we can use this statistic to do t-test of the population mean when population variance is unknown. So because we do not know the population variance, we have to use the sample variance and the sample standard deviation instead. So for example, if we want to do a two-sided hypothesis test, so H0 null hypothesis is we assume the population mean equals to the mu 0. And the alternative hypothesis is the population mean mu is not equal to mu 0. Then we get this test statistic. Then if this statistic is stayed in the critical region here or the other side for the two-tailed test. So if for the one-tailed test is either in this area or in the other side of the critical area, then we will reject null hypothesis H0 and we're in favor of H1. And at the significance level alpha. So this area has the probability alpha if for the one-tailed test. If for the two-sided test, then this area is half alpha, and this also has other side of the area half alpha. So this T alpha is called critical value. So we will compare the t-test statistic with this critical value. So next we will show an example. So the Edison Electric Institute has published figures on the number of kilowatt hours used annually by various home appliances. It is claimed that a vacuum cleaner uses an average of 46 kilowatt hours per year. So if a random sample of 12 homes included in a planned study indicates that vacuum cleaners use an average of 42 kilowatt hours per year, and with the standard deviation of 11.9 kilowatt hours. This suggests at the 0.05 level of significance that vacuum cleaners use on average less than 46 kilowatt hours annually. Assume the population of kilowatt hours to be normal. So from this problem description, we have H0 null hypothesis, which we want to test, is mu equals 46. So the population mean mu equals 46. This is the hypothesis of null hypothesis we want to test. And we form a one-side test here because the question is less than 46. The question is want to know if it is less than 46 from the sample information. So we form a one-side test mu less than 46. And significance level is alpha is 0.05. So if we look at this figure, this alpha is stay here. We do not consider other side, the positive side. In this example, we consider the negative side. So if we find the critical test statistic t less than the critical value here, although this is symmetrical, so t alpha here is minus t alpha, right? So if we find the t-test statistic lower than minus t alpha, because we want to test if it is less than the mu value. So if in this area, then we will say the test is significant and will reject the null hypothesis. And from the sample, the information is sample average 42 and sample standard deviation 11.9, sample size 12. So we have all the information. So next is just first is calculate critical value. T is minus 1.796 at 0.05 significant level. So minus 1.796 here at 0.05 significant level alpha. So which means on the left side of minus 1.796, the area has 0.05 probability under this density curve, right? It's symmetric. But here we only test the minus side because we want to test if the hypothesis is less than 46, right? So we have t critical value minus 1.796. Then we calculate the t-test statistic using the sample information, the sample average, then minus mu 0, here is 46, because this is what we want to test. So sample average minus the null hypothesis, 46, then divided by the sample standard deviation, divided by square root of n sample size. So this statistic will have t-distribution of 11 degrees of freedom. So we get t equals minus 1.16. And if we look at this figure, 1.16 is on the right side of 1.796, right? So minus 1.796 here, then minus 1.16 maybe here. So minus 1.16 is not in the critical region, so we do not reject the null hypothesis. And we can also see if minus 1.796 here will leave the left side of the probability is 0.05, then minus 1.16 here will leave a large probability, then 0.05 on the left side of this test statistic, right? That's why we calculate the p-value of the probability of a t-distribution less than minus 1.16 and 11 degrees of freedom. So we get that this p-value is 0.135. So p-value is larger than 0.05 also. And t-statistic is larger than the critical value. So we do not reject edge 0 here and conclude that the average number of kilowatt hours used annually by home vacuum cleaner is not significantly less than 46 from our sample. Right? So we just have a conclusion for the t-test used for the population mean and when the variance is unknown, and this applies mostly for the small sample problem. So say the sample size is less than 30. Why? Because if the sample size is very large, for example several hundred, so we can safely use normal distribution, or say we can use z-test. We do not need to use t-test. We can use z-test because when sample size is very large, so the degrees of freedom very large, the t-distribution is almost very approximately same as a normal distribution, a standard normal distribution. So we can safely use normal distribution. But in the small sample size, when the population is normal, but we get a sample size is less than 30, so we have to use a t-test if we do not know the variance of the population. So if we know the variance of the population, we can use normal distribution both in a small and a large sample. Because the test statistic, we use the population variance here. So the test statistic will have normal distribution, right? But in a t-test, in a small sample from a population normal, we do not know the population variance, so we use the sample information, sample standard deviation here. Also under the small sample size. So these two conditions will lead us to use a t-distribution. Thanks for watching.